Hello dear aspirants, this is Dr. Sourav Sir's class. We are now solving our National Boards of Higher Mathematics questions, previous year questions from, this question is from our 2017 paper. So the paper, so the question says us that the characteristic polynomial of a matrix A belongs to M5R. That means M5R means the set of the matrices of order 5 whose entries are real. So is given by the characteristic polynomial. That means our characteristic CHA is equals to x to the power 5 plus alpha x to the power 4 plus beta x cube, where our alpha and beta are non-zero real numbers. Okay. So what are the possible values of the rank of A? Okay. So easily we can see that from our characteristic equation we can take the common factor x cube out. Then the inner part will be my x square plus alpha x plus beta is equals to 0. This is the characteristic equation, no? Yeah, let me change my color. Otherwise, the multicolor options will be so. Yeah, okay. So, which implies that means our x cube is equals to 0. That thing implies there are three eigenvalues whose are 0. Exactly three eigenvalues, they are 0. Now the rank is at least 2 corresponding to the non-zero eigenvalues. So if the both the eigenvalues of this thing are non-zero, then the rank at least be 2. At least be 2. Okay. Now the possibilities of the Jordan blocks corresponding to 0, what can it be? As our, if our for the 0 case, three things can happen. That's this thing, first case, the null matrix for, and the other case, this thing can happen. In that case, this 0 and this 0 shares the same eigenvector, and this thing are nothing. So our algebraic multiplicity of 0 is what here? Our algebraic multiplicity is 3, but our geometric multiplicity is 2. And here the AM and GM both are 3. Now after that, in that case, the geometric multiplicity be 1, and this 0, this 0 and this 0 share the same eigenvector. So our geometric multiplicity is 1. Geometric multiplicity is what? That is the number of the distinct eigenvectors, or the dimension of the eigenspace. So our geometric multiplicity is 1 here and arithmetic multiplicity is 3. So corresponding to the first possibility, the rank can be what? Then the rank will be, from these two, the rank will be 2. The total rank of A will be 2. That is our rank of A will be 2. And this case, our this one occurs, so our rank will increase. So my rank of A can be 3. It's obvious, no? And this case, this one and this one occurs, so rank of A can be 4. So what are my answers? So my answers are 2, 3 and 4. These are the possible ranks of A with satisfying all the conditions given in the question. Hope you understood. Thank you guys.